Hello, welcome. In this short video, let us look at some examples illustrating algebra of complex numbers. Specifically, we'll look at how to convert expressions in terms of complex numbers into a simple polar form. So, we'll look at expressions consisting of complex numbers to convert them into polar form. The first one is a complex number given in x plus j by form, that is 1 plus j square root of 3. So we can easily convert this one into the polar form by finding the amplitude and phase of this number, which is given by r is equal to square root of x square plus y square, which is 1 plus 3, which is equal to 2. And theta is given by tan inverse of y by x, which is equal to tan inverse of square root of 3 by 1. Which is equal to tan inverse of square root of 3, which is given by pi by 3 radians. Therefore, polar form of the complex number 1 plus j square root of 3 is equal to 2 times e power j into pi by 3. Now we have a real number minus 5. Let us look at how to convert it into polar form. It is given by 5 multiplied by minus 1, which is equal to 5 into e power j pi. Here r, that is amplitude, is equal to 5 and the phase is equal to pi. The next example is minus 5 minus 5j. Here r is given by square root of 5 square plus 5 square, which is equal to 5 into root 2. And theta is equal to tan inverse of minus 5 by minus 5, which is equal to pi plus tan inverse of 1. Since both the values y and x are negative, the theta, that is the angle, should be in the third quadrant. Therefore, it is equal to pi plus tan inverse of 1, which is equal to pi plus pi by 4, which is 5 pi by 4. Therefore, the complex number minus 5 minus 5j is equal to 5 square root of 2 multiplied by e power j into 5 pi by 4. The next one is 1 minus j into square root of 3 power 3, that is cube of this complex number 1 minus j square root of 3. For this problem, it will be easier if we can convert the complex number 1 minus j into square root of 3 into polar form and then apply the cube. So 1 minus j square root of 3 is equal to square root of 1 plus 3 multiplied by exponential of j times tan inverse of minus square root of 3, which is obviously equal to minus pi by 3. Therefore, this is equal to 2 times e power minus j pi by 3. Therefore, 1 minus j root 3 power 3, that is cube of this complex number, is equal to 2 times e power minus j pi by 3 power 3. And 2 cube is 8, and e power minus j pi by 3 into 3. And these 3 cancel each other, these 3's cancel each other, and then we are left with 8 into e power minus j, which is equal to minus 1. Therefore 1 minus j into square root of 3 power 3 is equal to minus 8. Let us look at another example of polynomials, that is 1 plus j power 5. Here 1 plus j is equal to square root of 1 plus 1, that is the amplitude, multiplied by e power j into tan inverse of 1. That is 1 by 1 is 1. Therefore, this is equal to square root of 2 e power j pi by 4. Therefore, 1 plus j power 5 is equal to square root of 2 into e power j pi by 4 whole power 5. So, this is equal to 2 power 5 by 2 multiplied by e power j into 5 pi by 4. That is 4 root 2 multiplied by e power 5 pi by 4. Now let us look at an example where we have a polynomial multiplied by another complex number, that is square root of 3 plus j power 3 into 1 minus j. In this example, again, it will be easier if we can convert the individual complex numbers into polar form and then apply the cubes and product. That is, we have square root of 3 plus j is equal to square root of 3 plus 1 multiplied by e power j into tan inverse of 1 by square root of 3. And we know that tan inverse of 1 by square root of 3 is pi by 6. Therefore, we have 2 times e power j into pi by 6. And for 1 minus j, we have square root of 1 plus 1 into e power j into tan inverse of minus 1. Here, the y value is negative and the x value is positive. So, the angle should be in fourth quadrant. That is, the angle should be minus pi by 4. So, this is equal to square root of 2 e power minus j pi by 4. Therefore, the final value, that is square root of 3 plus j power 3 multiplied by 1 minus j is equal to 2 into e power j pi by 6 power 3 multiplied by square root of 2 into e power minus j pi by 4. This is equal to 2 cube is 8, and then we have square root of 2. So, it is 8 into root 2 multiplied by e power minus pi by 2. That is 3 into pi by 6 is pi by 2 minus pi by 4. Therefore, the final result is 8 root 2 multiplied by e power j pi by 4. Next example is we have a fraction or ratio of two complex numbers. We have a ratio of two complex numbers, 2 minus j into 6 over square root of 3 divided by 2 plus j into 6 over square root of 3. This is equal to, now we have to convert them into polar form. That is, the amplitude is 2 square 4 plus 6 square by 3, which is 12. And then angle is e power j into tan inverse of minus 6 by square root of 3 into 1 by 2. In the denominator, we have the same amplitude, which is square root of 4 plus 12. And then we have e power j into tan inverse of 6 by root 3 into 1 by 2. You can clearly see that the amplitudes are same, so we can cancel them. And the phase term is e power j into tan inverse of minus square root of 3 into e power minus j into tan inverse of plus root 3. And we know that tan inverse of root 3 is pi by 3, and minus tan inverse of minus root 3 is also equal to minus pi by 3. So we have e power minus j pi by 3 minus j pi by 3. Therefore, the final result is e power minus j into 2 pi by 3. Thus, to convert any expression consisting of complex numbers into polar form, we basically have to convert the individual complex numbers into polar form and then finally either multiply or divide based on the expression. Thanks for watching.